Hi guys, a very good morning to everybody present here. Uh, we are just waiting for a few people to join in more. So just allow us like 2 minutes so that we can start the session. Meanwhile, if you have any questions for us, please type down in the Q&A session so that we can take it up and answer those. Thank you. All right, thank you so much for your patience. We will start the session now. So Swati is our mentor who will take up the session. Swati, over to you.
Hi, everyone. Good morning. So I'll be your host for today's session. And today what we'll be covering is we'll be talking about SQL versus NoSQL and which is better and why. So understanding everything around these two. As we are already aware, there are many databases which are available in the market, and knowing which one to choose can be an extremely tough call there, right? So an excellent way to start excluding some points is to first have a clear understanding of the main differences between SQL and NoSQL databases. So in our today's session, we are going to present a detailed comparison between these two different types of databases regarding their structure, schema, scalability, the queries, the transactions, and also we are going to have a quick historical context based on both of them so that we can understand from where it all began. So before we delve into, talking about SQL, NoSQL, why not we talk about if there is someone new from among you guys? Let's try and understand what is database initially, or what do we understand by it? So anyone who might be aware or someone who is new to this concept, databases are the backbone of all modern information systems. So since computers, we know they store contemporary databases. The data can be of any size, or it could be complex as well. There are many ways to collect and arrange data depending on the usage and the type of the data which you want to store. So a basic definition of database would be it's an organized set of logically connected data. So the information it transforms into helpful knowledge when you try and give some structure or maintain to fit the user's requirements. So apart from storing the data itself, our database, it also helps, keeping the relationship between the data points which are there. So in broader sense, a database is an integral set of information about a system and the procedures, which involves for maintaining and the usage of the data. So unlike spreadsheets, we all have worked on spreadsheets, Excel files as well. Multiple users and application access the storage at once from the DB. Okay. Now, what are the databases they are used for? So you might have a better understanding of it. Like from a broader spectrum, if we talk about your banking systems, now we know everything is being digitized. All our banks are digitized. You are able to access your information through mobile apps. So your banking systems, they keep databases for clients, the accounts, the credit, transactions, loans, etc. Your airline traffic also, it keeps the information. Our universities also, they have the databases to record the information about the students, about the faculty, the management, and everything, right? The credit card transactions, you talk about the commerce or the e-commerce business, they also have the data about the consumers, the products, the various price catalogs, etc. The dispatch and delivery, all about that. The human resource, the HR department also have, it stores information about the employees. Every organization has it, right? Employees, paychecks, taxes, benefits, etc. So the list goes on and on over here. It's just I'm giving you a brief idea about how crucial databases are for any business type. So with modern user interfaces, the backend is hidden when accessing a database. Okay, so many users are unaware that they use one, daily. So you might be using a DB, but you might not be aware of that, it's actually a database that you're trying to access, right? There are different types of databases. So there are many different types of databases currently which are available for us with, each of with their own benefits and drawbacks. So every database type, it creates a specific environment. It gives you an environment for storing the data and the retrieval of the data, as well as the relationship between the, information over there. So the traditional started from relational databases, which store data in a table-like format. Then you have object-oriented databases, distributed databases, data warehouses. Again, it's data warehouses. They integrate data from various sources. So it's kind of like a warehouse or a storehouse, you could say. Now the new thing that you might be hearing is NoSQL database. They are, diverse types. They focus on high availability of data at all times. Also, they are, proving crucial, or you could say important at times. Now we have data called as big data, with large volumes of unstructured data. You can go for NoSQL. You have graph database. These are a type of NoSQL database. Okay, they happen to focus on the relationship between the data points. You have OLTP databases as well, open source databases which are available, the cloud database for the cloud computing, along with the cloud computing flexibility, multi-model document or JSON database. Again, it's a NoSQL type. You have self-driving cloud databases also, which in general term is called as autonomous DBs. So there are many kinds of DBs which are available, the kinds of management system you could go and, work on, but that all depends on what kind of business you are trying to, work on. What is the requirement you have? What's the use case? Okay. There are different components of databases. So let me now move you to a whiteboard for that. So there we'll be talking about components of DB. So I just think that before we start drawing the comparison, be aware of database as in whole, what it stands for. So there are basically 5 main components in your DB. The first that you'll have is a hardware. Then we have the software component, data, procedures, and the access language. Now, talking about each one of them one by one, hardware, hardware, it encompasses the physical devices that, connect computers with the real world. Okay. When it comes to databases, servers, storage disks, and various data collection devices which are there, they get included in the hardware component. Okay. That are required to run and populate a database. Software includes a wide array of programs which are there, which are used to access, manipulate, and control the databases. So on the lower level, the software, it also includes the OS, okay, on which the database reside, the network for the communication, the network, and the software to access the data. Now, the next thing, which is actually quite essential, that is the data. Now it's an important fact about an item or event which the database can save. The third thing, the data requires processing, right, to gain meaning and become an information. So data could be any random thing that you try to put over there. After being into the system, you try and try with the help of queries, transaction, you try and draw meanings out of that data that you've already fed. So additionally, processing extracts insightful details from the data and aids in decision-making procedures over here. The next that we have is procedures. So database procedures, they include all the functions operating within a storage. Whether, we talk about the regular backups which are going there, or, you want to generate some reports or other day-to-day operations or procedures, these are just an instruction set that run in the DBMS. Any query, any transaction that you are trying to run, that is going to come up in your procedures. Then you have database access language. Okay, this. Now, database access language is the programming language which is used for the operations, like you want to insert something, update, delete, modify. So if you're working on maybe, SQL, you'll be writing a select query to select something from the maybe like employee table. Okay. So this will come into your access language. This is the language which will help you to query in your DBMS, get information out of it. So databases, they execute queries in the database access language directly. Okay. Now, the next thing after this is, what is a DBMS? What is database management system? So database management system, it kind of serves as an interface. It kind of serves as an interface between the user or the application. It could be an application and the DB itself. Okay, so DBMS is an interface. This particular program, it allows direct communication with the database, where you are permitted to do data retrieval, update, optimization, storage of data as well. Okay. Now, the next important point is that should come to your mind is why these databases, they're important. Why there is a need to have a database. Why DBs are important. So as we've been talking a lot around it. Database system, it stores essential data, right? About a business, about any business. The data, when analyzed, it becomes valuable information about a company, about the organization, and helps in decision making process. So you need to collect the information, you need to store the record somewhere. It's helpful later on in later stages where you're kind of trying to analyze for your own business perspective. Okay. Likewise, a database, it helps build an archive as well. It's kind of like an archive, right, about the business. It's making the company more robust and aware of where it's headed when making any choices, when regarding any decision making. So storing data about an interaction helps provide insight into the information to help the company develop further and increase the profits. So there are many advantages again when using a system with a database, like independence between programs and data. So you are separating metadata from the application. That use data is a key attribute. Again, there would be minimal data redundancy, improved data sharing. So databases are a company resource. Okay, so that is, I suppose, what I have seen in my whole career is DBs, they are important or integral part of any organization for the record purpose. Okay, so they are a company's resource that many employees in sectors use. So specific internal and external users, they operate the database, and each person or group has specialized view of the data. Again, greater data security. So DBMS, it has some administrative functions which help control the security over the sensitive information, through authentication, privilege, or the user roles that we provide over there. So that was about a quick introduction about DB or database. Now moving on to the next thing, which is we'll be talking about blob storage for unstructured data. We've already talked about database, and it's a high level understanding of how databases work. It helps in evaluating the alternatives. So databases, the five basic components that we've talked about, which involves the whole DB. Then the next thing, another 5 components that come into play are related to database is, one is the interface language or any API, then a query processor, storage, indexes, and metadata. So interface language or API, now each database defines a language or API to interact with it, right? So it's going to cover the definition, manipulation, query, the language, query language, and control of data and transaction. The second is a query processor, the CPU of the database. Now its job is to process incoming requests, perform needed actions, and to give you back the result. The third is the storage, the disk or the memory space where the data will be stored. Indexes, it's a data structure which helps you to quickly locate the queried data in the storage. So that's why we have indexes. Then the next and the last is metadata. So meta information of data, about the metadata or meta information of the data, the storage, the indexes, everything will go in the metadata information. Okay. So this was about inside a DBMS, inside a database, what all things we could have discussed. The next is, to understand different types of storage for different kinds of data. The first you might have heard quite common would be tabular data. Tabular data. Now, tabular data is for structured data, where you have a proper structure for the data that you are putting into your database. So each record, so with the name tabular means there'll be tables, and each table is going to have rows and columns. Okay. So each record has the same number of attributes of the same type. So rows, also called as records. Okay. And these are columns, or you can also call them attributes. Fine. Now there are two kinds of applications. One is OLTP, which is online transaction processing. So OLTP, it captures, store, and process data from transactions in real time. Okay. OLTP works with real time. The next kind is OLAP. Now this is online analytical processing. Okay. So analyze, the work of it is to analyze the aggregated data, historical data from OLTP applications. So analytical processing is for analyzing the data. Okay. Now OLTP application, they need data stores that support, low latency reads and writes of individual records. OLAP application, they need data stores that support high throughput reads, okay, and a large number of read-only records. So when you talk about OLTP, or over here, OLTP, relational or row-oriented, you could say, database. So relational database management system, you might have heard of the term RDBMS. Okay. So one of the earliest data store. So data here in RDBMS is organized in tables. These tables, they are normalized to reduce the data redundancy and to have better data integrity. Okay. Now tables, they have keys. Again, there are two kinds of keys. One is primary, another is foreign here. Okay. So primary key, that's a minimal set of attributes that it's going to uniquely identify a record or a row in the table. Okay. Foreign key is going to establish relationship between tables. Okay. So foreign key is for the relationship between tables. This uniquely identifies rows. Okay. So query and transactions, they are coded using SQL here. Okay. For RDBMS, the query and transaction, they are coded in SQL language, which is structured query language. Okay. Now, relational databases, they are optimized for transaction operations, and transactions, they often, update multiple records in multiple tables. There are indexes, which are again optimized for frequent low latency writes of ACID transactions. Okay. One important thing that goes in SQL is ACID properties. Okay. We are going to talk about ACID transactions. ACID, the full form is atomicity, consistency, isolation, and durability. We'll get into the ahead of it. And there are plenty to choose from. If you want to work with SQL, you want to work with tabular data, there are plenty of options that you can go for. You can go for MySQL, PostgreSQL, MySQL in RDS, which is relational database service, as in of, AWS. Azure, you have Azure SQL database and so on. So there are many options available which you can go for. Another which was your OLAP, as we've seen that OLTP is row oriented. OLAP is columnar. Okay. So while transactions are on rows, analytical properties are computed on columns. Okay. So OLAP application, they need an optimized column read operation on a table. And one way to achieve it is by adding column oriented indexes. Here we have column oriented indexes. It's again going to work with RDBMS only. Okay. OLAP and OLTP, they work on RDBMS. Example would be columnar column store indexes in SQL Server, or indexing in PostgreSQL. So that is where your OLAP will come into play. Now for big data, storing blob storage data lakes, they became popular. Okay. So that is for big data. So again, now blob storage, what is blob storage? The next kind is, one was we've seen, which is tabular. One comes, which is blob for unstructured data, where you don't have a definite pattern of data. Okay, it's unstructured. So the file system is the simplest and the oldest data store. File systems, where we have files, try put everything onto a file. We use it every day. We use it on a daily basis. We create different files, store different kinds of information into it. And blob storage, talking about blob storage, it's a hyperscale distributed version of the file system. Now blob is used for unstructured data. Blobs, you could say backronym is binary large objects. Okay, or the full form if you need, it is binary large object. You might have seen CLOB, BLOB kind of data types. So blob is for that. You can store any kind of data into this, therefore blob data store has no role in interpreting the data. It supports CRUD operations like create, read, update, and delete at the file level. And the directory of file path is the index. Okay. So what is a file path? The directory, that is the index. So here you can quickly locate and read the file, but locating something within a file requires a sequential scan. Okay. Documents, images, audios, video files, they are stored in blob format. Okay.
All right, guys, we will just conduct a quick activity just to see how many of us are attentive and are able to understand, what Swati is sharing with us. So we'll just conduct a quick poll right now. I just need all of your attention. You'll see the poll in next few seconds on the screen. Meanwhile, just would want to let you know that you can put down your questions in Q&A sessions. So we have the poll right here. So the question says, does NoSQL have a dynamic schema? So your options you have in front of you is yes and a no. We have very limited time for this poll. This poll is going to let me know how much of, how many of us are attentively listening right now. All right, so we have the answers and let me check. Oh, wow, it's amazing that almost all of us are listening attentively, Swati. So it's a great thing. I think you can take the session ahead and we can discuss a little more on this topic.
Sure. Okay, so that was about blob storage. Moving on to the next thing, which is NoSQL. you know, the one that, we'll be having a comparison with SQL, NoSQL for semi-structured, unstructured data, kind of data. Okay. So NoSQL data stores, they cater to semi-structured data types. They, where you have key value, wide columns or trees, documents and graphs. So there is something called as key value data store inside this. There is a wide column data store. We have document data store and graph data store. So before I move on to that, just to give you a quick recap of SQL database, so that to have it in your, just to strengthen the concept. SQL, it stands for structured query language. It's a programming language that's, been widely used in managing RDBMS. It's from since, you could say, in early 1970s. So in the early years when storage was expensive, SQL database, it focused on reducing the data duplication. Okay. Fast forward today, we talk about SQL. It's widely used. Again, it's quite common, and used for querying relational databases where data is stored in rows. There are tables and that are linked in various ways. There are, the information is interlinked. There is a relationship between them. One table record may link to one another or to many others, or many table records may be related to many records in another table. So that kind of relations, we have these relational DBs. They offer fast data storage and recovery, but one thing they lack is they can only have structured data inside it. Talking about NoSQL here, NoSQL is a non-relational DB, okay? Meaning it allows different structures than a SQL database. There is no rows and columns or, tabular structure over here. It gives you more flexibility to use a format that best fits the data, the kind of data that's incoming. Okay. So NoSQL doesn't mean that you don't have to use SQL. It's just NoSQL do sometimes support some SQL commands, but it's just the correct term, or to define it, you could say not only SQL over here. Okay. One important thing, the question that I saw, which says, NoSQL has a dynamic schema or not. So it has a dynamic schema. As I've already mentioned, it allows different structures, different structures for storage and also for your records. The records that we're talking about here, you might have documents, you might have a kind of like a graph structure and so on. So here the fields could be different, but if you worked with SQL, you'll know it's going to, in a table, it's going to have just one kind of data. But here the schema is dynamic, inside a collection, the schema is dynamic. You can have any kind of, record in it with different or varying fields. Okay. That is why we say it has dynamic schema. So here again, the different kinds that we were talking about, the key value data store. So key value data store is a dictionary or hash table. Okay, key value, hash table, or kind of like a dictionary format. Okay, so it is designed for CRUD operation, and there is a unique key for each record. So CRUD means create, read, update, and delete. Okay, now the values, they do not have a fixed schema, no fixed schema. Okay, it's dynamic again, and can be anything from primitive values to compound structures. Okay, so key value stores are highly partitionable. They scale horizontally. There is a term which you learn later on if you start your journey in NoSQL, which is called as horizontal scaling or sharding. Okay, so key value data stores, it can be scaled horizontally. One popular key value data store I could give you an example is called as Redis. Okay. The next is wide column data store. Now, a wide column store, it has tables, rows, and columns, but the names of the columns and the types, they may differ from each row in the same table. Okay. So when we say wide column, please don't get confused with the normal or the traditional RDBMS. It have tables, but again, it's not, the schema is not fixed, different column values, different column names, and each can have different data in each record you can have. Okay. So wide column data stores, they are highly partitionable. It has a notion of, column families that are stored together. The logical coordinates of a cell are row key, column name, and version. Okay. So the example of wide column is HBase, which is Apache HBase. Then you have document data store, very much popular again. You might have heard of DB in use, in practical use, everyday use, which is MongoDB. And now document data store. They, these stores, or, consider having documents consisting of nested objects. Tree structure, they have a kind of like a tree structure, something similar to XML, JSON format, or YAML. Okay. Now in key value store, the value is opaque, but the document store exploit the tree structure of the value to offer richer operations. Okay. So here you can have embedded documents as well. So embedding or the data model, one would be embedded data model, which will be followed in document. The example of this is very widely used is MongoDB. Then we have graph database or the graph data stores. These are like document stores, but they're designed for graphs instead of document trees. Okay. Now this kind of data store will be suited to store and query, let's say a social networking site. Okay. Example of this you might have heard, might have seen somewhere, Neo4j. So that was about, just to give you a quick introduction of NoSQL, the kinds of data stores which are there. Now, a quick comparison between the two. But before we do that, let's see the historical context that I said, to have that historical context again. Now, relational model of data, we are talking about the historical context of both of them. Relational data, RDBMS, it was introduced by, or you could say the father of RDBMS was E.F. Codd. Okay. And 4 years later, Raymond Boyce and Donald Chamberlain, they introduced SQL. So RDBMS concept was given by E.F. Codd. SQL was given by Raymond Boyce and David Chamberlain. Okay. And this SQL, it was initially developed to query IBM's system. It was used with IBM. Okay. It was a database management system at that time. Now, it did not take long until SQL, it became a massive success. It's again, these days also, it's quite popular, and it's incredible that how the practicality and ability to reduce data duplication is there, right? Now, the consequences of using SQL is more data. Now, as we know, with the advent of World Wide Web, the data is ever increasing. It's not stopping. As I speak, there is data, because the session is live streamed. It has to go somewhere. Yeah. It just doesn't remain into the environment. Where does it go? We are not aware of that. So that is the consequence again. It gets stored. Maybe you are streaming it for YouTube, it gets stored on the YouTube servers. Okay. So the consequence of having so much data is, we know the internet's growth is, it's increasing rapidly. And as new sources and volumes of data kept disrupting the world, relational databases, they started struggling there. Okay. You're not able to use relational database to store or handle the humongous amount of data which is producing. So it gave way to non-relational systems like you might have heard of Google's Big Table or Amazon Dynamo, which started making their own way. The focus here was on scalability and rapid application. Okay. Now, over the years, with the advent of non-relational databases, NoSQL became very popular. Now, talking about NoSQL, who coined the term? It was coined in the year of 1998 by Carlo Strozzi. Okay. So though it existed, quite from a longer period of time, the term it came into existence in 1998, and the person was Carlo Strozzi. Fine. So if now we move on to the SQL and NoSQL comparison. Let's first talk about the structure. Okay. Now, SQL databases, they organize and store data by tables. In SQL, you have tables, okay, with fixed columns and rows. When we talk about NoSQL, the data can be stored in n number of ways. As we've talked about different data stores, document, wide column, key value pair, graph databases. That is one big difference. The second difference comes in the form of schema. Now, SQL database, they require a fixed predefined schema. And all the data for SQL, the schema is fixed. Okay. And all data must follow a similar structure to, get stored. Consequently, a lot of preparation regarding the system is required upfront to, prepare the schema as well. So plus the flexibility over there is also compromised. What if at later stage, the kind of, data is changing, it's variable, it's varying. In that case, you might have to change your whole DBMS, right? Everything, the scalability is not there. The flexibility is not there. So the flexibility is compromised, considering that potential modifications in structure can be made, and it would be complex, highly complicated, and may disrupt the entire system until you get it back together, right? In turn, when we talk about NoSQL, considering NoSQL, it follows a dynamic schema for unstructured data, because here the data could be of any type, structured, unstructured, the blob kind, it could be anything over here. Since it does not require a predefined structures, modifications are easier to execute here. Therefore, NoSQL have greater flexibility. Okay. Sometimes the flexibility may also compromise the reliability. Okay. Despite the advantages. That has all to be taken care of when you're starting with it. The next is the scalability. Okay. Now, regarding scalability, SQL databases, they follow a vertical approach. What we call it as scale up also. Okay. So in DBs, this means that it is possible to increase the amount of data in a single server by adding more power. Now, power in terms of the processor, the RAM, the storage, the disk space, those things, SSDs. So this is called a scale-up process. Okay. Now, on the other hand, NoSQL, it scales horizontally. For this, we call it scale out. Okay. So since they scale across commodity servers, which means the more servers are added to the pool of the instances or the resources, okay? More DB instances are there and data can be distributed across those resources. Now, join operations, they allow to connect and relate pieces of data. So generally, NoSQL DBs are not designed to support join efficiently. They can, but they are not designed for that purpose. Objects can be on different servers in non-relational database systems without being concerned about the table joins or, from multiple servers there. Thus, NoSQL, it allows for easy scaling by the process called as sharding data and having a routing layer over there that can redirect the query to the appropriate shard. Okay, shard means a whole kind of a server itself. So, which makes the NoSQL database highly scalable and fast to query. However, here it compromises with data integrity, okay, and does not follow the ACID approach, which is followed in SQL. So scaling out in RDBMS is generally difficult, okay, it's not done over there, okay, because in SQL, we have to keep in mind the concept of data integrity, the ACID concepts, which are related to relational database, okay. Now the queries, they are also different, as previously mentioned, as these SQL has been around us for a long time. Thus, it is widely admired as a nature and popular language that benefits from a reliable reputation. So it is incredibly efficient when it comes to querying data. Querying means try to get data out of DB. Manipulating, retrieving data from relational databases. Another great SQL advantage is that it is relatively easy to learn. It's very easy. The syntaxes, the queries, they are easy. So you can learn SQL quite faster. Meaning that, the marketers or the business analysts can use it without necessarily requiring technical staff help. So that is easy for them. When it comes to, running NoSQL queries, NoSQL queries, it might not be as straightforward. Now, if you are aware of Mongo queries, you'll see there are so many involvement of, kind of these brackets which are there, what bracket to use when, where you are closing it, and so on. So it might be as straightforward as SQL database, since it usually needs to execute extra data processing as well. Apart from just the declarative style, what we see over here, the data is all, unstructured. The processing is also different. Okay. So these tasks are usually performed by data scientists or developers themselves. So all in all, how to run queries in NoSQL database, it depends a lot on the database which is in question. Okay. For instance, in MongoDB, a request data from the JSON document database, it is necessary to, you have to specify the documents with the properties over there. That result should match and apply the following function. For example, if you kind of try to view the results, you could do db.collection.find. Other popular solution would be to create the query functionality directly into the application layer and not into the database. There we use something called as map reduce, making use of JS functions for mapping and reduction. Okay. So database transactions, one kind of transactions already discussed, which is ACID. Another is called as base. So SQL data type, it typically follow the ACID properties regarding the transactions. ACID stands for atomic, consistent, isolated, and durable. So let's take a closer look to understand these properties separately now. Atomic means it's going to ensure that all the data in the database is necessarily validated. It's validated. If each data transaction is not properly carried out, then the process returns to the initial state. Consistent means it ensures that a processed transaction of data does not damage the database structural integrity. Okay, it has to be consistent. The transaction should not hamper the integrity. Isolated, each transaction is isolated from other data transaction. Hence, a transaction cannot compromise the integrity again. Okay. Durable. Durable means the durability, the data which is related to the process transaction will not impact the manipulated data, even if the transaction is failing. So as one can observe, the ACID model secures that the transaction is reliable and consistent here. Therefore, DBs that follow this model are the best fit for organizations and business that cannot take any risk, for invalid and interrupted data transaction or any other kind of error. Maybe, when we talk about like financial institutions, there they have to follow the ACID model. So relational database management systems, they are ACID compliant. Okay. So NoSQL approach usually goes against ACID principle. Some NoSQL database can also integrate and follow ACID rule, but they do not promise the overall integrity. In non-relational DBs, the data reliability and consistency is not a number one priority over there, okay? Considering that it can compromise the speed and high availability. So there we have something called as a base model, okay? Base. So base means basically available, soft state, eventually consistent. So this is base. Fine. Basically available means it ensures that data availability by expanding and replicating the data across the clusters. So you have the data available at all times. Soft state is for ensuring the database consistency. Now, eventual consistency is the consistency is not immediate, but it has to be achieved and maintained. Okay, so it is still possible to read the data. So NoSQL database, they follow the base model and which offers more elasticity than the ACID model. Okay, the base model is more suited for businesses that prioritize high availability, scalability, and flexibility of data transactions. For instance, a social networking app, it handles, a massive amount of data that are often not very well structured. So thus, in that case, a base model might make it easier to store the data. Yep. So as we, kind of move towards, the closure of, we'll now be talking about when to use which model. So before we do that, we just have a quick poll for you to understand.
Yes, so we just have a quick poll that we will run right now in regards to the topic that has been covered. So you will see the poll in next few seconds. Here it is. So the question here is, who was the father of the relational database model? You have all the 4 options here. So the first option says Raymond Boyce. The second is Donald Chamberlain. The third one is E.F. Codd. And the fourth one is none of the above. This poll will definitely, give us an idea about your attention level throughout the session. It is just gonna end in few seconds, so kindly go for it. All right, so the poll has ended. And we have a quick question for you, Swati, from one of our, attendees. So Prince wants to ask as to what is the difference between primary key and unique key?
Okay, sure.
Thank you.
So primary key and unique key, talking about that, primary key in a column of a table, it's going to uniquely identify each tuple in that particular table. So it enforces integrity constraints to the table. So only one primary key is allowed to be used in a table. You can have only one primary key. It cannot accept any duplicate or null values inside it. The primary key value in a table changes very rarely. That would be a very rare case where you will be changing it. So choose your primary key carefully. Okay. And only one key per table is allowed. Now, talking about unique key. So unique key constraints, it also identifies an individual tuple in a relation or table, but a table can have more than one unique key, unlike the primary key. So unique key constraints can accept only one null value for column. Okay, so unique key constraints are also referenced by the foreign key of any other table. It can be used when someone wants to enforce a unique constraint on a column and a group of columns, which is not a primary key. Okay, so you can have, for example, there is a table, employees. Okay, there would be one could be an ID, just a simple ID for each employee that you have. Let's say the ID for you could be the serial ID that we have. Okay, that could be the primary key for each column, that it's different. Another could be the employee ID, okay, that we have, and employee ID over there in the table could be a unique key along with maybe the name of the person. So now you can group, with the help of unique keys, you can group columns together as well. So it's not restricting you to have just one column as a key. Primary key, you are restricted to only one column. Unique, you can have as many columns as unique. Okay. So the difference here would be the primary key does not accept null values, whereas unique key can accept null value for a column. A table can have only one primary key, whereas there can be multiple unique keys on any table. Okay, so that could be the answer if you're looking for.
All right. Well, we have one of our attendees asking whether you will get a certification of this particular, session that you've attended. Yes, all the participants present here will have the certification on your email, right? And also, I would just like to inform you, as we were talking about, database management, and this session was all about it. We have various courses that helps you learn all of these courses, right? So we have, as you're aware, that database and data science is one of the most in-demand tech roles at the moment, and is one of the highest paying jobs. You would be surprised to know that, the average package that we have given to a fresher in the past for data scientist role is 10 to 12 lakhs. And more surprisingly, the highest package to a fresher has gone up to 25 lakhs. So I would just want to ask, I am sure that, it is a very exciting, start to the career where somebody would want to, start with a good company, with a good package like 10 to 12 lakhs or probably over and above that. So I would just want to understand how many of us would want to build their career in data science. So we will quickly run a poll here so that we understand how many of us present here would want to go ahead with data science role. So here is the question: would you like to start your career in database technology? The poll is just going to end in a few seconds. Thank you so much for that. I mean, somebody from, our team or probably me will get in connect with you for all the people who wants to make, career in database. We will connect for a quick counseling session so that you have a clarity how things are when you choose a career. right? So, all right, so we will just wait for like a couple of minutes to check if we have any more questions coming up from the participants. Even if you have any question, you can just type down in the Q&A session so that we can take it up. Our mentor Swati is present with us, so she will be able to answer the questions that you have related to database.
Sure. Let me talk about the different career options that you'll have once you get into this field. So there are a variety of industries with database technology. um, Careers for those interested in jobs, ranging from information security to data to analysis. Okay. Or now here, the different careers that you could choose from would be the database manager. Now, a database manager is the one who focuses on the management and maintenance of database or several databases for a company. The next would be to have your career into data analyst role, who is a professional who specializes in data analysis and interpretation of data. So in this role, you will be, as a professional data analyst, you are going to gather information, gather data on the business procedures and methods, translate it to the data sets into readable access, and you are going to try and find your analysis reports, for the career, for the business growth. Then you have a data scientist role. He's a professional who's going to specialize in analyzing the raw data, transforming it into an easily readable and understandable data set over there. So here, data scientists, they use data science procedures, statistics, machine learning, and programming to review the data and form conclusions. Okay. The next you might have heard of would be information security analyst. Is a person, a professional who's responsible for protecting information from cyber attacks, hackings, etc. So typically, information security analysts, they protect networks, computer system information with firewalls, encryptions to make them as secure as possible over there. So that's also related to DBMS. Okay, so you will be creating data recovery plans, troubleshooting the systems, and test prediction methods. Then you might have heard of DBAs, database administrators. They are professionals who manage a software database for any company, right? So here, you'll be managing databases that hold the user accounts, records, surveys, and similar items, and allow access to whosoever, based on user authentication. You have data modeler, who's again a professional who's chiefly responsible for designing an organizational data structure for any company or organization. Software engineers, the most common, you might have heard of it. One who specializes in developing softwares, business applications, network control systems, operating systems for any companies and organizations there. So these are the various roles that would come, before you, once you start with your career in DBA. So when to use acid or base model depends entirely on what kind of what kind of application or what kind of data you have to use. So now that we've covered the main differences between SQL and NoSQL, it's time to understand when to use one, right? So before making a final decision, it is important for you to consider the following aspects. The type of data that you have in hand, which is in question, the amount of data that will be coming for the storage purpose, the how will your database will be managed. So that these points have to be taken in account of, when you are working with SQL. So regarding the first aspect, SQL, they are more suitable option Then NoSQL, when your data integrity and consistency is the key. Okay, when you have to take care of that, along with there is a structured kind of data. So there is often the misconception that relational databases are not good option to handle large amounts of data. That is not exactly true. Like you can work with the PostgreSQL, MySQL, and can handle very respectable amounts of data. However, since RDBMS they use SQL have a fixed schema, okay, that is a fixed schema that you have over there. There it becomes difficult. That's a challenging task where you have a fixed schema and the kind of data which is coming in that is unstructured. So in that case, you might have to move to another option. Okay, maybe like business where you're trying to handle big data. There you might not have RDBMS working perfectly. So at first sight, it might seem that having a fixed schema is limited. Okay, but again, it depends on the purpose, what kind of application you are trying to build. So SQL databases, they are most appropriate option for handling management systems like payroll management system or processing the maybe like flight reservations. Now, most banking institutions also, they rely on SQL DBMS. Okay. So since we've seen that relational databases, they are typically ACID compliant, meaning that data transactions, they ensure integrity, validity, and reliability. Plus, SQL might limit some features, but it is also very mature technology that you can work on. Moreover, when to use NoSQL now? So NoSQL databases are able to store various types of data that do not need to be structured. So where you have large amounts of data, which is unstructured, any kind of data is just coming in, and you have to store that. So non-relational databases, they allow for great adaptability and flexibility. It makes it more suitable choice when you are handling large sets of unstructured and unrelated data. Okay. The more extensive the data set, the more likely a NoSQL database would be a better option over there. Okay. They tend to excel in the fields of scalability and availability requirements. They might compromise with integrity and redundancy. Okay. So you have to weigh in the options and the kind of application that you are trying to build and then work on it.
Guys, you can continue typing your questions in Q&A session. We will pick it up as soon as we can. Thank you.
Yes, I see a question there which says Firebase is SQL or NoSQL. It is a NoSQL. It's a cloud-based NoSQL. Okay.
All right, so as we see that all of the questions has been answered, and I believe we have covered everything for today. So Swati, do you have anything to add up for today's session?
No, I'm like almost done. Though if I have any questions, it will be okay.
All right. I think we have answered all the questions. There is one last question that I can see. How do we know when to use either acid or base model? Would you like to take it up?
I just worked on that. I just discussed that question, regarding SQL and NoSQL and the ACID-based property.
All right. In that case, I think we are done with this session for today.
Let's have one last poll, Ruby. So it'll be just a trivia that you guys can have and see whether you are thorough with it or not.
All right, surely. So yes, we have the last poll here. Can you identify the components of acid? You have 5 options for a change this time. So the first one is atomic, second is consistent, third is isolated, fourth is durable, and the last one is all of the above. Let's see who gets this right this time. We're just ending the poll quickly. All right, so we have the answers to it. So yes, 83% of the people were pretty attentive and they did understand what was going in the session. We are glad that, all of our attendees here are, being attentive and enjoying the session. That's really nice. I think we will end this class for the day today. Thank you so much for your time. And we look forward to see you in other sessions. Thank you so much.